So our parent rational function is the equation y equals 1 over x. And the graph looks like this. We have these two portions of the graph, one in the top top right, and one in the kind of bottom left. And we have these two asymptotes that split up the graph. We have a vertical asymptote, x equals 0, and we have a horizontal asymptote, y equals 0. So sketch the graph and write the equation for each transformation of the parent function y equals 1 over x. So over here I have a reminder of what that graph looks like, and now we're supposed to translate the graph up 3 units and left 2 units. And if we look at this parent graph, if we translate the graph up 3 units, what's going to change is the location of the horizontal asymptote. If we translate up 3, that asymptote is also going to move up 3. So on my graph I can sketch a horizontal dotted line at positive 3. So this is the new location of the original horizontal asymptote. It was here, now it's up here at 3. We're also going to translate left 2, and that's going to move our vertical asymptote to the left 2. So at negative 2, I'll sketch in my vertical asymptote. And with the asymptotes graphed, it's really easy now to graph the function as long as we graph a few key points. So from where the asymptotes intersect, from right where they cross, we can travel kind of out 1 and up 1 to get a point on our graph. And then if we travel out 2, we go up 0.5. And if we only go out 0.5, we go up 2. So with those 3 key points, now we can sketch the graph kind of hugging those asymptotes, trying not to cross them. And then we have symmetry with the bottom left portion of the graph. So out 1, down 1 to graph a point, out 2, down a half, and out a half, down 2. And then we can connect the points and hug those asymptotes. And we have a sketch of the parent graph, but now that it's been translated up 3 and left 2. To write the equation, we have y equals, the horizontal translation goes on the bottom with x. So since we translated left 2, we actually write x plus 2. And then at the end, to translate up 3, we add on a plus 3. Let's look at one more. So we are going to translate the graph down 1 unit, reflect over the x-axis, and stretch it vertically by a factor of 2. If we translate down 1 unit, the horizontal asymptote is going to move down 1 unit. So we'll sketch that in, down 1 unit from where it was originally. We're not translating left or right at all, so the vertical asymptote is going to remain the same right on the y-axis. Now we have to consider what happens when we reflect over the x-axis. And if we reflect over the x-axis, this portion of the graph that's kind of up here in the top right is going to flip down and now be in the bottom right. And this portion that's kind of in the bottom left is going to reflect up here to kind of the top left. And then when we stretch vertically by a factor of 2, we're going to have to think about those key points that we normally graph and stretch them out vertically by a factor of 2. So if I look at where my asymptotes intersect, I'm going to have a portion of my graph up here in kind of the top left. Rather than go out 1 up 1 from the intersection of the asymptotes, I'm going to go out 1 up 2 because of that vertical stretch. Instead of going out 2 and up only a half, I'm going to go out 2 and go up 1. And then instead of out 0.5 up 2, I'm going to go out 0.5 and go up 1, 2, 3, 4. And with those 3 key points, I can connect them and hug those asymptotes to get a sketch of the graph. Make that a little better. And then same goes now here in this kind of bottom right portion. So out 1, down 2, out 2, down 1, and out 0.5, down 1, 2, 3, 4. Connect the points, hug the asymptotes, and we have a sketch of this transformed graph. The equation y equals, when we stretch vertically by a factor of 2, we have to multiply by 2, times 1 over x. The portion down here with the x isn't going to change at all because there was no horizontal translation. And then we did travel or translate down 1. This could be rewritten as y equals 2 over x minus 1.